Now we are going to discuss Gate Live online classes for civil engineering revision class for on transportation engineering, which I had already discussed previously. This subject whose weightage ranging from 8 marks to 10 marks. That itself, the weightage itself says it is a very important subject. By the way, transportation engineering, I can say it is a relatively easy subject when compared to other subjects in civil engineering technical paper. Okay, so let's focus on these sessions on the subject. Let's focus on the subject on these sessions in these sessions. Okay, starting with the problems. The first question is a GATE 2025 2-mark question, set 2. What is given in the question? All of you have a glance at this question. Have a look at it for a couple of minutes. For a minute, we'll discuss about it then. We'll discuss about the solution of it. This is a GATE 2025 solution question. What is mentioned? It is told on a 2-lane highway, a horizontal curve of radius 300 meter is provided. The design speed on the highway is 80 km per hour. The length of longest wheelbase is 7 meter expected on the highway. Extra widening required is dash. Round it off to 2 decimal places. Listen, extra widening, the questions are very common on it. We generally provide extra width of the road at the curve for 2 reasons. One is for mechanical reasons due to off tracking. One is for psychological reasons for comfort purpose. So mechanical extra widening is given by the formula NL square by 2R. Psychological extra widening is given by the formula capital V by 9.5 root R, where V is the speed in kilometer per hour. This is an empirical formula. What is the type of the formula? This is an empirical formula. Empirical formula means the units which is given in the formula we need to substitute in the same units. So the number of lanes n is equal to 2. 2-lane highway is mentioned. L is the length of longest wheelbase, 7 meter. R is the radius of horizontal curve. Why? Because we provide extra widening only at the places of curves. And V is design speed. As I told you in kmph, therefore V is 80. And R is in meter, 300. So on substitution of these values in the formula, 2 into 7 square upon 2 into 300 plus 80 upon 9.5 into root or 300. Calculate and tell me the value of this extra widening. Calculate and tell me the value of this extra widening, my dear students. Transportation engineering is mostly about know the formula, substitute the values with proper units, calculate properly, get the answer. Calculate and tell me the answer, my dear students. I'll be waiting for your answer. Very good, Vijayalata S. We got it 0.65. What is the units? On rounding off to two decimal places, we got the value to be 0.65 meter. As per the key, the answer is mentioned 0.60 to 0.70. Any value in this range holds good. You will be getting 2 marks. Have a look at this question, all of you. If you have any doubts with the problem, formula, or else the solution, any doubts regarding this question, please let me know regarding this. I'm giving a minute here and then we'll move to the next question. If you have any doubts, please let me know the doubts. If not, please message me. It is clear to all of you. Any doubts, my dear students? Please let me know. Okay. I hope it is clear to all of you. Thank you. We'll move to the next question then. The next question is stating the free flow speed on a highway. This is a question from traffic engineering, my dear students. This is also from GATE 2025, set 2. It's a 2-mark question. The free flow speed of a highway is 100 km per hour and its capacity is 4,000 vehicles per hour. Assume speed density relation is linear. For a traffic volume of 2,000 vehicles per hour, the possible speeds from the options below are is or are. That means this might be an MSQ also, because he had asked choose all the possible speeds for this given volume. Okay, and what is the type of question? It's a speed density linear relationship model. Okay, so how to solve this first? How to approach? What are we asked? First, we need to know this. First, we need to know this. That is, for a linear speed density relation, for a linear speed density relation, I hope what I'm writing is visible clearly to all of you. Please once confirm me this in the chat box at least. I hope what I'm writing is visible clearly to all of you. Say yes or no. For a linear speed density relation that I had written here. Thank you, Adi. Yeah, for a linear speed density relation, what is the formula for velocity? Velocity is given by Vf into 1 minus k by k upon kz. where V is velocity, Vf is free flow speed, K is density, Kj is jam density. Okay, and this is relation model. And in a linear speed density relation model, we also know Q is equal to Kv. Q is equal to Kv. And Q max is equal to Kj upon 2 into Vf upon 2. Q max is equal to Kj upon 2 into Vf upon 2. That's given by Vf free flow speed into Kj jam density divided by 4. That will be your Q max. Okay. Now, the free flow speed on a highway is mentioned, capacity is mentioned. That is Q max, maximum capacity is also mentioned to us. From that, if he had given us the free flow speed, can we find out Vf? We know Qmax is equal to Vf Kj upon 4. Free flow speed is 100 kmph and its corresponding capacity is also mentioned, 4000 vehicle per hour. From this, what is Kj? Qmax 4000 is equal to Vf is 100 into Kj upon 4. What is Kj then? Tell me the value of jam density Kj. Please calculate and tell me the value. Answer, my dear students. Very good, Ardi. Very good, Vijayalata. We got Kj jam density 160. What is the units, my dear students? This is in vehicle per hour, and Vf units is kilometer per hour. Therefore, density should be vehicles per kilometer. Density unit should be vehicles per kilometer. So that kilometer get cancelled, you will be having vehicle per hour. So units of density is vehicles per kilometer. Kj. Am I clear to all of you? Please let me know if I am clear to all of you. Now we got the value of Kj, my dear students. Now as we discussed, V equal to Vf into 1 minus K upon Kj. Yes, V is equal to Vf into 1 minus K upon Kj. This is the speed density relation model, my dear students. In this, we know Vf is 100 into 1 minus K is the density. We don't know the K value of K, and Kj we got it to be 160. So let's focus on working out of K. And how do we get K? We also know from this linear speed density model, Q is equal to Kv. And at a traffic volume, that is capacity of 2000 vehicle per hour, what is K? Q is equal to Kv, my dear students. When Q is 2000, that is K into V. We can substitute in terms of V itself then. because we don't know the value of V also. K is equal to 2000 upon V. We know only VF. We don't know V as well. So I am substituting this here. V is equal to 100 into 1 minus 2000 by V into 160. This gives us a quadratic equation. Tell me this equation. That is 100 into, if I am taking 160V as common, 160V minus 2000. From this, please develop a quadratic equation and tell me the equation, my dear students. I'm giving a minute here. Develop a quadratic equation, that is V square minus something. Get the value, get the equation. Yes, Anupriya, this is a since this is a revision class, I'm just discussing the previous questions along the concepts, if required, are discussed along with the questions. So this is a kind of concept through questions, not questions through concept, concept through questions. Since it's a revision session, and this is our first slide, what we have discussed, that is in Gate 2025 questions I had started. So you can have a screenshot of it. Thank you for asking. And this is also a question from Gate 2025 traffic engineering. It is mentioned the linear speed density relation. So we have this equation for linear speed density, and Qmax is given by Kj by 2 Vf by 2. And from that we got this equation. I want everyone to develop a quadratic equation from this. So if I am multiplying 160V, that gives us 160V square minus 16000V minus, thank you, plus we will be getting, because or else we will be getting like this: 160V square is equal to 160 into 100V minus 2000 into 100. So we have this equation now. From this, the quadratic equation will be like this: 160V square minus 16000V 160V square minus 16000V plus 2 lakh equal to 0. Let us divide this whole equation with 160. Then what happens? V square minus 100V, because 116,000 by 160 is 100, plus what is 2 lakh by 160, my dear students? Tell me the value of 2 lakhs upon 160. What is the value of 2 lakhs upon 160? Very good, Ardi. 1250. So we got V square minus 100V plus 1250 equal to 0. This is a equation in which we need to find the value of V. Solve the equation and get the value of V by using the formula ax square. If this equation is in the form of ax square plus bx plus c equal to 0, the roots can be found like x is equal to minus b plus or minus root over b square minus 4ac upon 2a. So in this, you will be getting two values. If you substitute plus, you will be getting one value. If you substitute minus, you will be getting another value. From that, tell me both the values. I'll be waiting for your answers. All of you give a try. This is very important. Great, Vijayalata. What about others? Others, please give a try. Very good, Anupriya. Very good, Tangavini. 85.36, 14.64. Therefore, our options are option A, option C. So, this is an MSQ, multiple select question. That means in which, because how can you identify? Choose all the possible speeds, he told. That is, it might be greater than one speed. So, if you pick up all the correct options, that is, if you pick option A and option C both, then only you will be getting 2 marks. If you pick only one option, A or only C, you will not be getting marks. But I'll tell you one more thing. For MSQ, you don't have any negative marks. So if you feel it is MSQ, try to attempt that question. If you know it is an MSQ, don't leave that question. Try to attempt that question itself at any cost. But before attempting that question, you need to know it is MSQ. You need to identify. Sometimes in the paper it is being mentioned it is MSQ. Sometimes it is not mentioned directly, but it will be given indirectly like this. Hmm. Is it clear to all of you? Please let me know if anyone have any doubts in this question. One speed is 85.36, the other speed is 14.64 units kmph. Option A and option C. I'm giving a minute here. Please let me know if anyone have any doubts in this. If not, we'll move further. If it is clear, please let me know in the chat box. Thank you. Okay, my dear students, I'm going forward to the next question. This is also a question from GATE 2025, set 2. This is also a question from GATE 2025, set 2, my dear students. It is a match the following. In the column 1, we have vehicle damage factor, passenger car unit, that is the nouns or the units, perception reaction time, California bearing ratio. Definitions I can say. In the column 2, you have on what is it dependent, on what is it related to. Column 2, you have stability of subgrade soil, capacity of roadway, design of rigid pavement, design of flexible pavement, stopping site distance. Try to match these things and tell me the answers. This is a simple fundamental question on this concept. Tell me the answers, my dear students. Yes, very good, my dear students. Option A is the answer you had chosen. Vehicle damage factor. First, let me explain each and everything. Vehicle damage factor is related to design of fixed flexible pavement because vehicle damage factor. So one goes to D. One goes to D. We have it in three options. Vehicle damage factor is used to account for the damage caused by different vehicles in the design of flexible pavement. So a highly loaded vehicle will be having a higher vehicle damage factor. Next we have passenger car unit. Passenger car unit is used to convert. It is a unit that is used to convert different vehicles to equivalent number of passenger cars. That means you might be having different types of vehicles in day-to-day life, like tractors, bullock carts, auto rickshaw, cycle, cars, lorry, etc. So everything we need to convert it into a single unit. We call it as passenger car unit. We call it as passenger car unit. So PCU is related to capacity of the roadway. And next we have perception reaction time. Perception reaction time is related to stopping sight distance. It is a reaction time before stopping a vehicle upon seeing any obstruction. So next, California bearing ratio. It is the it is a stability of subgrade soil (CBR). It is nothing but a test or penetration test used to evaluate the strength of subgrade soil. So CBR 4 goes to A. So 1 goes to D, 2 goes to B, 3 goes to E, 4 goes to A. Option A is our answer. Right pick. Very good. Moving to our next question. Listen, my dear students, this is a question from surveying. I just wanted to include this geomatics. I had just included this since this is a question from GATE 2025 as well. These kind of questions are very common. And geomatics is also a bit related to highway engineering. That is the reason I had included it here. What is given? The forebearing of line AB and BC, forebearing of line AB 60 degree, forebearing of line BC 122 degree. What and interior angle ABC is dash. So what we do first is, in order to find the interior angle ABC, let's go with the back reverse. First we'll find back bearing of line BC minus forebearing of line back bearing of line AB. We'll go with this back bearing of line AB minus forebearing of line BC. We need to have B common in both the things because that is interior angle ABC is nothing but angle B located between A and C. So we know the forebearing of line BC. First, let's find out back bearing of line AB. Let's check, is it, how much is the value? Is it greater than 180 or less than 180? It is just 60 degrees. It is, which is less than 180. So add 180 to this. Back bearing is 180 plus theta. If theta less than 180, so that is 240 degree. We got the back bearing 240 degree minus forebearing of BC 122 degree. That gives you 118 degrees. Angle ABC, we get it as 118 degrees. So the answer is 118 degrees, my dear students. Please let me know if anyone have any doubts in this. If not, please message me. It is clear in the chat box so that we'll move to the next question immediately. Going to the next question. It is also a question from Gate 2025 Sec 2. This is a question related to highway materials. Which of the following statements is or are incorrect? He is asking you to identify the incorrect statements. I will look at this question for a couple of minutes and please let me know the answers. It might be right or wrong. I just want your answers from your end. Please. Okay, students, listen. Which of the following statements is or are incorrect? See, the first statement is stating bitumen having lower softening point is preferred in warm climates. No. In warm climates, we will be preferring bitumen having higher softening point in order to prevent rutting and bleeding. To prevent rutting and bleeding, we generally prefer bitumen with higher softening point. Therefore, option A is incorrect. Next, viscosity of bitumen influences, yes, it affects the mixing and compaction of bituminous mix 100%. It is a right. This is not incorrect. The air voids in the range of 3.5% are required to arrive at optimum bitumen content. Optimum bitumen content is determined by maintaining the air voids in the range 3 to 5% only. This is also right. The purity of bitumen can be determined by solubility test. Yes, this is also right. Therefore, our option A is only the incorrect statement. Option is option A. If it is clear to all of you, we'll move to the next question. If you have any doubts, please let me know. I'm giving a minute here. Okay, the next question, my dear students. This is also a question from GATE 2025 set 2. It is stating the point where road alignment changes from tangent to a curve is known as. This you can also say it's a question from geomatics also. This you can relate or correlate it to both the subjects. What is mentioned? The point where the road alignment changes from tangent to a curve is known as. Tell me the answer. Can you guess the answer, my dear students? Point of curve. Point of curve is the answer. Point of curve is location where tangent ends and curve begins. Point of curve is location where tangent ends. That is, road alignment changes from tangent to a curve. That is where tangent ends and curve begins. What is point of tangency? Tangency means where curve ends and tangent begins. Curve ends and tangent begins. That is, road alignment changes from curve to tangent. If in the equation it is mentioned, road alignment changes from curve to tangent, we call it as point of tangency. And point of intersection, point where two tangents intersect. Points where two tangents intersect is known as point of intersection. Point of deflection is not a standard term, but it is from horizontal curve geometry. It's from horizontal curve geometry. Therefore, our option is point of curve. Option C. Am I clear to all of you? Am I clear to all of you? Thank you, Ardi. What about others? If it is clear, we'll move to the next question immediately. Please let me know if anyone have any doubts in this. Thank you, Anupriya. Next question also from GATE 2025 set 2, transportation engineering, railway and airport engineering, which is also a part of transportation engineering we have discussed. After applying the correction for elevation and temperature, runway length is 700 meter. Corrected runway length for effective gradient of 1% is dash meter. It is told after applying the correction for elevation and temperature, runway length after applying both elevation and temperature is 700 meter. To this you apply gradient 1% correction. Now the corrected length is dash. What is effective gradient here? Mentioned 1%. Listen, my dear student, I'm just explaining this. Effective gradient is mentioned 1%. As per IRC, Indian Road Congress 9157 is the code number, and ICAO, International Civil Aviation Organization. As per both these guidelines, if easy effective gradient is exceeds greater than 0.4, an additional correction an additional correction up to effective gradient of zero point 0.4, no correction is needed. If effective gradient is greater than 0.4, an additional correction of 20% of basic length is provided for every 1% effective gradient. If effective gradient is greater than 0.4, for every 1% effective gradient, an additional correction, that is increase of basic length, is provided. For how much? For every 1% effective gradient. From this, you have, after applying correction for elevation and temperature, you have the runway length 700 meters and effective gradient is 1%. For 1%, how much runway length is to be increased? 20%. So increase the runway length by 20% and tell me the increased value. 700 is not the answer, my dear student. Sorry. 700 is basic runway length. To this, you apply the correction, increase 20%. That will be your answer. Very good, Tangavini. What about others? So that is basic runway length is 700 plus 20%, 20 by 100 of basic runway length, because effective gradient is 1%. Very good, Ashika. That is 840 meter. For suppose if effective gradient is 2%, how much you need to add? 2 into 20 by 100, that is 2 into 20%, 40%. 40 by 100 into 700, like that. For the same question, if it is clear, if the effective gradient is 1.5%, for effective gradient 1.5%, what is the answer? Corrected runway length in meter. Tell me for this also. For effective gradient of 1.5%, what is the corrected runway length in meter? Very good. Very good, Tangaveni. Very good, Ashika. So all of you have a look at it. If anyone have any doubts in this runway length related to this problem, related to runway length, gradient, please let me know. I'll explain you. I'm giving a minute here. I'll wait for a minute and I'll move to the next question immediately. Which one, ma? Vijay Lata, please, sorry. Which part you are asked to explain again, please? This question, this question you are asking. Listen, as per International Civil Aviation Organization, if effective gradient is greater than zero point 0.4, okay, in the question, how much is effective gradient? 1%. Okay, what is ICAO telling? If effective gradient is greater than zero point 0.4, you need to increase the runway length by 20%. Increase the runway length by 20% for every 1% rise in effective gradient. Okay, so here the rise in effective gradient is 1% only. For 1% effective gradient, we need to increase 20% the runway length. Therefore, already the runway length is 700 meter. For that, we increased it as 20%. 700 plus 20 by 100 into 700. That is giving us 840 meter. Am I clear? Am I clear, Vijay Lata? Thank you. For suppose, instead in the question, if he told 1.5%, so how much we need to increase? For 1% as per ICAO increases 20%. For 1.5%, how much it is? Let's make it x. Let's go for cross multiplication. 1 into x is equal to 1.5 into 20. X is equal to 30%. If it is 1.5%, we will do 30%. If it is 0.5% only, we will increase only 10%. If it is 0.3% only, no increase. Why? Because if effective gradient greater than zero point 0.4, then only. When it is less than or equal to zero point 0.4, no need. Understood all? Have you all understood this? Next, the next question, which is also from GATE 2025 set 2. This question states the recommended minimum traffic growth and design period considered for structural design of flexible pavement as per IRC 2018 is dash percent and dash years. Minimum traffic growth and design period for flexible pavement, the codal provision is IRC 37 2018 is dash percentage and dash years. Tell me the answers. Tell me the answers. Theory question directly. As per IRC 37 2018, the traffic growth rate is 5%. Traffic growth rate is 5%, my dear students. 5%. And design of flexible pavement is 20 years. So 5% and 20 years are matched where? In option A. Option A is our answer. Hmm. Can I go forward to the next question? 5 and 20. Option A is my answer, my dear students. Can I go forward to the next question? It's a question from Pavement Design, Gate 2025, Set 1, 2 marks. It is mentioned during determination of bulk density, specific gravity of compacted bituminous specimen, the mass of air in specimen is 1260 grams. It is grams, my dear students. And volume is, mass of air in the specimen is 1260 grams and volume is 525 centimeter cube. Density of water is 1 gram per centimeter cube. Theoretical maximum specific gravity of the mix is 2.510. Percentage air voids in the compacted specimen is dash. First, how do you calculate it? That is, percentage air voids in the compacted specimen is given by the formula G theoretical maximum minus Z bulk specific gravity maximum, Z specific gravity maximum theoretical specific gravity G MTH. M means maximum, TH means theoretical, G means specific gravity. M means maximum, B bulk, MB, B for bulk specific gravity upon Z MTH, that is maximum theoretical specific gravity into 100. Now let's work out the maximum bulk specific gravity. Maximum bulk specific gravity, that is nothing but density of bitumen by density of water. How do you get density of bitumen, my dear students? How do you get the density of bitumen? Mass by volume. Mass is mass is 1260 grams by volume is 525 centimeter cube. 525 centimeter cube. What is density of bitumen? Tell me. What is the density of bitumen? Tell me. Vijayalata, Tangaveni, Ashika, Perarasu, Srinivashini, Adi, Anupriya, Ramesh. 2.4. Very good, Vijayalata. 2.4 gram per cc, gram per centimeter cube. Now I am substituting this here. Maximum bulk specific gravity of the bituminous mix is equal to 2.4 gram per cc upon 1 gram per cc. Gram per cc gets cancelled. ZMB is 2.4. Now use the above formula and substitute these values and find out percentage air voids. 2.51 minus 2.4 upon 2.51 into 100. That gives percentage air voids. Round it off to 2 decimal places. Tell me the answer. Very good, Ardi. Very good, Vijayalata. The answer is 4.38. Anyone, please, if you have any doubts, please let me know this. Anyone, if you have any doubts, please let me know. If not, we'll move to the next question. I'm giving a minute here for your doubts. Okay, I'm moving to the next question. This is also a 2 mark question from GATE 2025 set 1. This is a 2 mark question. The question is stating the speed density relation on a one-way single lane road is shown in the figure. See, up to a density of 10 vehicles per kilometer, speed is linear. Speed is 90 kilometer per hour. As the density increased, speed decreased and became zero. That is, at speed is zero means this is jam density. This 100 is kj. So the speed density relation is right line up to some distance and downward straight line. That is a vertical inclined line. It is in the form of a triangle. For this, he is asking us maximum flow on this road. So get the identify the value of u, identify the relation and tell me the slope and establish a relation between u and k first. Establish a relation between u and k. From that we will find q, v and k. From that we will find q. U and V both are same, my dear students. Speed in kilometer per hour. See, let us focus. Identify the slope from a density value of k from 10 to 100. Identify the slope on a density value of k from 10 to 100. What is the slope? Slope is how much? Y equal to mx plus c. M equal to dy by dx. Change in y upon change in x. Yet 10. What is the value of y? Tell me. Yet a density of 10, the value of y value, that is velocity, is 90. That is 90 minus, at 100 the speed is 0. 0 by, here x value density is 10 minus 100, that is 90 by minus 90. Slope is minus 1. Do anyone have any doubts in this? Slope is minus 1. Why is the slope negative? Since the speed y value is decreasing. Downward line slope is negative. Upward line slope is positive. So V can be written as a relation. From 0 to 10, V is V or U. V or U both are same. 0 to 10, V equal to 90 plus Y equal to mx. Slope is minus 1. X is 1. 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . k minus 10, k minus 10, because you for maximum flow we don't know the value of k, so assuming the value of k to be k itself or x, that is x minus 10, and minus 1 is the slope, that gives 90 minus k plus 10, that is 100 minus k. Speed density relation from this curve we got it as v equal to 100 minus k. Anyone have any doubts in this? Please let me know. Then we will move forward with this question. Up to this point, there is no slope. From this to this point, we found the slope, we established the relation. Therefore, we got v equal to 100 minus k or u equal to 100 minus k. Now, q is equal to kv. That is k into 100 minus k. That is 100k minus k square q. And he asked us maximum flow. For maximum flow, for maximum flow, dq by dk equal to 0. For maximum k, value of k, rate of change of flow with, for maximum value of y, dy by dx is 0. For maximum value of theta, d theta by dx is 0. Similarly, for maximum value of q, dq by dk, because we have this equation in k, dq by dk is 0. So what is dq by dk? 100k by k, d by dk of 100k is 100, d by dk of 2k k square is 2k is 0. From that I'll be getting 2k equal to 100, k equal to 50 kmph, sorry, vehicles per kilometer, k equal to 50 vehicle per kilometer. Now substitute this. I got the value of k, find the value of v, get the value of q. For k equal to 50, v equal to 100 minus k, because we know the relation, we established the relation. 100 minus 50, that is 50 again, kmph. And q is equal to 50 into 50, that is 2500 vehicles per hour. See, first from the diagram we established the relation. Next, we know q equal to kv, and we got the equation for q, dq by dk is 0 for maximum flow. From that we found q, we found k, we found v, from that we found q, that is q max. Please have a look at it and let me know if anyone have any doubts in this. I'm giving a couple of minutes here for this question. Please, if any doubts are invited, appreciated. Please let me know if any doubts if for anyone in this question. Second line, once more. Thank you. Second line, okay. V equal to 90 plus minus 1 into k minus 10. Okay. Listen, my dear students, this is 90. You are asking about this line, right? Is it? Please once confirm me, Tangaveni. What I had underlined. This line. Yes, okay. Listen. Listen, ma. He had drawn a diagram like this. Let me go to the next slide for a while. He had given a diagram like this. On y-axis, he is talking about speed. X-axis is talking about density. He had given us like this. That is a straight line with no slope, no decrease in value. Velocity is 90 at zero density, and that is practically at zero density means no vehicles are moving, and speed is 90 kilometer per hour up to a density of 10 vehicles per kilometer. As the density increases, we know speed value decreases. Speed value decreases. So it became zero. V is zero. Yet density is 100 vehicle per kilometer. He is asking us Q max. Q max is, we get it as the formula before going directly into Q max. If it is linear density relationship model, we would have applied Kz by 4, Kz Vf by 4. But it is not given linear model. Some places it is straight line. Some places it is downward line, like that. So we cannot apply this formula. But he is asking us Q max. But at any place we know one formula, Q is equal to Kv. So I want either V in terms of K or K in terms of V. So I am trying to write V in terms of K. So what I am doing is from 0 to 10, KV is, I am writing like this. K from 0 to 10, V is 90. And from 10 to 100, let the K be any value. V is how much? For any value in between this, K is equal to, already you have speed as 90. Now the speed as density increases beyond 10. What about speed? Increases or decreases? Tell me. Up to density of 10, speed is 90. After 10, speed increases or decreases? Line is moving downward. That is, slope is negative. Slope is negative means speed decreases, my dear students. Therefore, y equal to mx, m into k. But what is k? Up to 10 you don't require. Therefore, k minus 10. M is the slope. M is minus 1. Therefore, speed is 90. From that, the speed decreases by what value? By the value of slope, which is minus 1. And at any point of k, you need to find it out. K minus 10. Why you are reducing 10? Because up to 10, there is no change. It is 90. You had already included. For suppose in the equation on differentiation, we got k is 50. Now let's check it out with 50. At k equal to 50, where is k 50? At this value somewhere. At this value somewhere k 50, what is the speed? At this v is how much? At this k 50, what is v? From this we will be getting the answer. 90 plus minus 1 into 50 minus 10. That is 90 minus 1 into 40. 50, like that. Thank you. Clear. Thank you, Tangavini. What about others? Any doubts for anyone? If you can solve these type of questions, these are the rank deciders. Anyone, any more doubts? Please let me know. I'm giving a minute here. If not, we'll go to the next question directly then. Clear. Thank you, Ardi. Have a screenshot of this. Also have a screenshot of this as well. This is another question from GATE 2025 set 1, 2 marks. This is more over a question from geomatics engineering, and you can also relate it to highway engineering. What is given? Road A and road B are joined by a circular horizontal curve of radius 200 meter as shown in the figure. See, this is road A, road B are both are joined by circular horizontal curve. Road A and road B are tangential to the curve at the points C and D. A is tangential to the curve, B is tangential to the curve at points C and D. Had the curve not been there, straight roads A and B would have met at point E. The distance from C to E is 92 meter. Value of theta is dash. Angle is calculated only from consideration of Euclidean geometry and the data given in the problem. Okay, no problem. Calculate the value of theta. Directly use the geometry equation. This distance CE is given by radius into tan delta. Delta is theta by 2. From the geometry, I can directly write this formula, my dear students. CE equal to, if it is ED, that is R tan theta by 2. From that, calculate theta and tell me the answer. CD, where radius is equal to, sorry, CE, the distance is equal to radius into tan of the half angle. If this is theta, this is theta, this is theta, this will be theta by 2. And that, what is, how is R calculate, theta calculated? You know CE, you know R. Very good, Vijay Lata. What about others? CE is 92, R is 100, 200 is equal to tan theta by 2. Tan theta by 2 is equal to 0.46. Theta by 2 is equal to 24.8. From this, theta is equal to 49.6 degrees. The answer is from 48 to 52. Any answer is right as per the key. Hmm. Please have a look at it and let me know if anyone have any doubts in this question so that we'll move to the next question. Hmm. We have two questions in this slide, my dear students. We have a couple of questions in this slide. The first question states the maximum degree of curve that can be used for railways in a mountainous region. Maximum degree of curve that can be used for railways in a mountainous region. How much? As per railway codes, what is the maximum degree of curve you can use? We have a fixed value, no need of calculation, direct the equation. Tell me the value. The answer is 40. This is a 1 mark question from GATE 2025 set 1. 40% is the maximum degree. We can use it on mountainous region. Maximum degree of curve we can use on a mountainous region is 40%. Next, in the context of testing bitumen, which of the following statement is false? The depth of penetration of needle is measured in units of 1/10 of mm. Yes, the statement is correct. Penetration value is expressed in 1/10 of mm. Softening point is measured using ring and ball apparatus 100%. It is measured using ring and ball apparatus. Softening point is measured in units of time. Softening point is measured in temperature, degree centigrade. It is not measured in units of time. Ductility is measured in units of length. Yes, 100% centimeter or mm. So the option is option C. Option C. Very good. Option C. So any doubts for anyone in both the questions? C is false. Remaining all are true. And the maximum degree we can use is 40%. Maximum degree of curve. If both the questions are clear to all of you, I'm moving to the next question. All the vehicles that comes during a particular peak are during a 10-minute period within this hour. All the vehicles comes during a particular peak hour comes during a 10 minutes period within this hour. For suppose I am assuming in a complete day, if 6 p.m. to 7 p.m. is your peak hour, he is telling all the vehicles comes in a specific 10-minute time interval. Let's say some 6:20 to 6:30. Most of the vehicles are coming in this 10-minute period within this hour. 15-minute peak hour factor for this peak hour is dash. 15-minute peak hour factor for this peak hour is dash. All the vehicles during the peak hour arrive within a 10-minute period. To find what is he is asking to calculate. He is asking you to calculate 15-minute peak hour factor. Peak hour factor is given by the formula hourly volume by how many 15-minute intervals we have? 4. In 1 hour, you have four 15-minute intervals. Therefore, 4 times peak 15-minute volume, hourly volume by 4 times peak 15-minute volume. So here what is told? All vehicles arrive within 10 minutes period. 10 minutes means is it in this 15-minute interval or not? This 10-minute period means it is inside this 15-minute interval. Yes or no? Yes. 10 minutes period means you treat it as inside the 15-minute period. Therefore, peak hour factor is hourly volume, let it be V, by all traffic comes in this 10 minutes, that is in this 15 minutes only. So if hourly volume is V, peak 15-minute volume is also V. Why it is V? Because all the traffic is coming in this 10 minutes. Remaining traffic is very small, negligible. Therefore, hourly volume is V, vehicles per hour. That 15 minutes volume or 10 minutes volume is also V vehicles per hour. He asked you for peak hour factor for 15 minutes. That is V by 4V, 1 by 4, 0.25. If he asks you for 30 minutes, peak hour factor for 30 minutes, if he asks us in the question, that is hourly volume V by 2 into peak 30-minute volume. Peak 30-minute means again that 30-minute comes in, 10 minutes comes in this 30-minute interval. That is 1 by 2.5. This is how we calculate the peak hour factor based on the time. And peak hour factor, if he asks you for 10 minutes, that is hourly volume by how many 10-minute interval we have? 6. 6 into peak 15-minute volume, peak 10-minute volume, that is V by 6 into peak 10-minute volume is again V, that is 1 by 6, 0.167. So based on the question, we need to tell the answer. He asked us peak 15-minute hour factor. Therefore, the answer is 0.25. As per this question, during 10-minute peak hour factor, all the traffic is coming within this hour. Then at any time, we will be the same. If in the question, if it is told 50% of the vehicles during a peak hour comes in this 10-minute period, then it becomes V by zero point 0.5 V in the denominator. But it is told all the vehicles, therefore 100% of V will be V. If it is told some 80%, in denominator you have 0.8 V. If it is told some 50%, in denominator we have 0.5 V. If it is told some 90%, in denominator you have zero point 0.9 V, like that. Am I clear? Am I clear, Ashika? Okay, have a look at it. If any doubts, please let me know. I'm giving a minute here for this question. Be back in a minute. Hmm. So the next question, my dear students, in the context of pavement material characterization, the correct statements is are. What are the statements that are correct? Tell me the answers. Have a look at it. As per the timing schedule mentioned, we have a break for 1 hour from 6 to 7. We again have a session from 7 to 9 p.m. And we will be discussing very, very important questions, very, very important models in that session as well. Please don't miss out on any session. B, C, D. Okay. Let's check out Anupriya. Hmm. Load penetration curve of CBR test. Load penetration curve of CBR test may need origin correction due to non-vertical penetrating plunger of loading machine. Yes, it may need correction. Load penetration curve of CBR test. In the test, there'll be some plunger of the loading machine. Due to non-vertical penetration, there will be some correction need. So option A is right. Toughness and hardness of road aggregate are determined by toughness, hardness. See, toughness is determined by aggregate impact test, my dear students. This determines toughness. He willingly confused you. And hardness is determined by Los Angeles aberration test. But he given in reverse, respectively, he told. Therefore, this is false. Toughness is determined by aggregate impact test. Hardness is determined by Los Angeles aberration test. But he gave in reverse order. Therefore, this is false. Grading of normal bitumen binders is done based on viscosity test results. Yes, 100%, because we have VMA, VMA equal to VB plus VV, percentage volume of bitumen plus percentage air voids. VMA is voids in mineral aggregate. In compacted bituminous mix, VMA is equal to VV plus VB. Yes, 100%. VMA equal to VV plus VB. That's what we discussed now. Therefore, A, C, and D are correct. Only B is wrong. Clear? Anupriya, very good. You tried very good. But the thing is, he willingly confused you. Toughness, aggregate impact, hardness, abrasion test. He willingly confused us in reverse order. Very good try. Next question. Let's solve this question first. What is given? A vertical summit curve on a freight corridor is formed at the intersection of two gradients. Two gradients. This is plus 3% and minus 5%. So N1, N2. This is N. How do you get N? N1 difference N2. That is 3 minus of minus 5. 8%. So we got N. And what is the value of SSD? SSD. The design length in order to accommodate SSD. First we calculate SSD. VT plus SSD equal to VT plus V square by 2ZF. SSD equal to VT plus V square by 2ZF. What is V? 80 kmph into 5 by 18 meter per second into reaction time is 2 seconds plus V square 80 into 5 by 18 whole square divide by 2 into G is 9.81 into F is longitudinal friction 0.36, and he also gave us, yeah, V square plus VT plus V square by 2ZF. From that calculate SSD and tell me the answer. Dash meter. All of you calculate SSD and tell me the answer. How much is SSD? 1057. Why 1057? Vijay Lata, please have a look. Please convert it into meters per second. 80 into 5 by 18 meter per second into 2 time plus 80 into 5 by 18 whole square by 2 into 9.81 into 0.36. Once again, recalculate and tell me the answer. 114.35, 114.36. I am getting also the same. 114.3635 like that, in that range, 34 like that. Very good, both of you. Very good, Ashika. Very good, Ardi. Very good, Vijay Lata. Very good, RDS. Now we got SSD. Now how to get L, length of summit curve. Length of summit curve, we have it based on two conditions: L greater than S or L less than S. First, always assume L greater than S. Then L is equal to n square by root 2 capital H plus root 2 small h whole square. N is 8%, 0.08, because we got it N here, 8%, 0.08 into S is your SSD, that is 114.36 whole square, divide by root 2 into H. H is height of I of driver, 2.3, small h, this is capital H, height of driver's eye, small h is height of object, then only we require SSD. Capital H 2.3, small h 0.35. 2.3 plus small h is 2 into 0.35 whole square. Calculate and tell me the answer, my dear students. Calculate and tell me the answer. 117.8. Very good, Vijay Lata. What about others? What about others? Hmm. I'm getting it as 117.80 meter. Now, you need to check your assumption. 117.7. Very good. No problem. Very good, Tangavini. Very good, Vijayalata. Now you need to check your assumption. Is it greater than yes? That is SSD. What is SSD? 114. That is, now you got L 117. Is it greater than 114.36? Yes or no? Yes. That is, your assumption is right. Your answer is right. For suppose, if you get L equal to some 112, instead of 117, you get length of curve is 112 meter. Summit curve is 112 meter. Instead of 117, if you get 112. But what you took, L greater than S. Here what happened? L less than S. Then what we need to do? The formula will be 2S minus root 2H plus root 2 small h whole square by n. Then the formula becomes 2s minus root 2h plus root 2 small h whole square upon n. This will be the formula. When it will be applicable? If L less than S. But always we take the assumption L greater than S. We will calculate. We check if it is greater than S. If it is greater than, we stop it. This will be our answer. If less than S, then we move with this formula. Then the answer is 117.8. In the key, it is 117 to 118.5. Any value holds good. 117 to 119 is present as per the key. As for the answer key, it is given 117 to 119. So have a screenshot of this slide. I'll move to the next slide. First is calculation of n. From after that, calculation of SSD. Then calculation of L greater than S or less than S, L greater than S. Check for the value correctness. If it is correct, that's your answer. 117.8. Have a screenshot of this. Okay, we shall stop here. Stop this session here. Again, we will be having a session at 7 p.m. That is in 1 hour exactly. We have a break for 1 hour. Please do join me for the next session. Also inform your friends and other classmates to join the next session. That is also going to be very important for your gate examination. Is the session clear to all of you? Is the session helpful to all of you? Thank you, Ardi. Thank you, Ashika. What about others? Okay, my dear students, do join me immediately at 7 p.m. for the next session. Thank you, Tangaveni. Yes, Tangaveni, I will show it. Yes, please have a screenshot of it. L is equal to R tan delta by 2. That is the formula. Okay.